guys. So, for those of you who don't know me, my name is Alfredo Calaitzis. People call me Freddy, and I do work for TeensInAI, and my job is to do applications of artificial intelligence for good. Good is quite an absolute term. I would say for better. Things that make things better for society. And more specifically, human rights. How can you use AI to monitor the state of human rights at a planetary scale? So let me just motivate the problem really quickly. I'm officially starting the count now. So let's look at the case of Darfur. Does anyone? And it's actually in Western Sudan. And why is it important? Why is Sudan a very important place for us to look at? And what's happening in Sudan right now is a genocide. And for the last 15 years, the Sudanese government has been roaming around the villages, burning villages that are mostly occupied by non-Arabic communities. And the reason that's been done, well, there's a lot of political reasons, but one can say that it's driven from climate change, actually. Well, that's one of the reasons. These different demographics have been co-living in the same country for a long time. Why all of a sudden they started having conflicts? That's because of climate change. So because the natural resources are being limited, and now the government is finding more reasons to go around and do what they call ethnic cleansing. And Amnesty International is one of the organizations that my team has been partnering with, and they're very much interested in monitoring human rights abuse. And you wanna find evidence of what's going on. You go out in the field, you take pictures, you shoot bootleg videos, and you show to the world what's going on. But this really because it will really say the full story. There's no consistent complete collection of data that show you how much distraction is happening day by day, week by week. It doesn't really tell a complete story, and it doesn't allow you to connect the dots with what people on the ground observe, right? Okay, so can we help here? Let's look at a demo. I know I'm going really slow, but I want to show you the application. And right. So this is a demo of an application, a computer vision application where. So we chose a strip of Darfur. This is a strip of Darfur here. Not very visible. And we asked people, volunteers of Amnesty, people who support Amnesty, and they were willing to annotate data. This is called crowdsourcing, by the way. So you're a volunteer of Amnesty, and you're asked you look at a little tile, and then you have to say, is there a human presence there or not? So anything that is green has been labeled by a volunteer as human presence. Okay? So they do this, with thousands of volunteers. You can use all that power, human power, to collect all this data. This is pretty good quality labels for the rest of Darfur. Let's see. This is human presence now. Anything that is green is human presence. Sorry, anything that is red is predicted as human presence. Look at this. It's like all over the place. Now you might say, well, oh my God, this is hopeless. Like, it's found tons of false positives, right? It's like, it doesn't work that well. Maybe useful. But actually, when you zoom in, you realize actually, yeah, there is something going on there. Interesting, right? Who's impressed by that? It's pretty cool. So it really shows you the power. I'm going to stop the demo here. This is the takeaway, is that it really shows you the power, how you can scale the monitoring application in a countrywide level, right? But what's the problem here? The problem is that to do this, you really rely on high resolution data. So High resolution data is like data that you can, like you can zoom in and you can look at the walls and the houses and all for someone to take this data, right? You can do it from Google Maps, you can scrape it, but you cannot use it, like, it's illegal. So you need a lot of money. So one way you can get around that is by using low resolution data. Now, what is low resolution? How much time do you have?
It's okay, you have time.
Okay. You guys tell me when you get bored, okay? This is low resolution. Like, okay, this is what a low resolution image look like. I mean, what's in here? Can someone tell me what can you see? Pixels. Can you, like, okay, like you can kind of make out faces, right? Yeah. But can you tell me where am I in this background?
Bottom left.
But that's only because you see my Slack photo, right? But okay. But actually, can you tell who this guy is? Maybe some of you met him yesterday.
Is it Michael? No?
Ah, okay. So this is too low resolution to tell. Now, what if I enhance the resolution? Ah, there's Michael and a deer. So that, exactly what I just did, is called super resolution. Well, this is a gimmick. I did this artificially, but turns out machines can do this. Well, okay, let's first see some popular science examples, popular fiction, science fiction examples of super resolution. Anyone heard of CSI? Yeah? Every season of CSI pretty much contains this trope, or MacGyver, for those who are from the 80s. That's fantasy, but this is reality. This is what super resolution actually looks like. So you can get very good enhancement. I didn't do this, by the way. This was work that was done in 2016, and ever since deep learning became a big thing, we realized that computers are not only good at recognizing stuff like detecting faces and objects and doing a lot of different classification tasks, but anyone heard of the phrase, if you can't create it, you can't understand it? Right? It's like, well, it's like a quote. So if you want a computer to understand what it sees, it has to be able to recreate it. So now we have computers that can create new faces of people that don't exist, but they're very realistic. So in a similar line, now we can ask a computer, create a high-resolution version of that, and it gets the job done. But the devil is in the details. Look at here. Look at the texture on the hat, on the scarf. It looks nothing like that here. So what the computer has done is it created a realistic-looking high-resolution image, but has done nothing to recover. You're really relying on very fine details. And the computer is not really good at recreating those details that are important. But the catch is, so the reason why this is what we call it. So let's say